Grade 11's ready to make it maths? Of course I'm ready to make it maths. Okay, so today what we're looking at is the sine rule. So what the sine rule says, we're just going to kind of write it down. In fact, let's just check it. So we've got our triangle, the same one we had before. I'm going to take one of these angles. Let's start with C, why not? Top left there. I'm going to say that if we look at 5, the side opposite this angle, and divide it by sine of 25, that's going to be equal to any other side and over the sine of that angle. So let's take this side and this angle, because again you see this side and this angle, they kind of correspond to each other, they're opposite each other. So if we go, well, this is sine of 35 degrees and this is 6,79, those two should equal each other. And finally the same is going to work for the last side in the triangle and the last angle. So if we take this angle and this side, then sine of 120 on the denominator and 10,25 in the numerator, there we are. Yeah, let's just check that that works though. So let's just pull up the calculator here. And I've got it, there we go. And go, okay, so 5 over sine 25, 11,83. And just remember that number, and let's go 6,79 divided by sine of 35. Pop it in the calculator. Do you get the same answer? Well, hopefully 11,83. And again, you know, give or take a decimal place here or there, 10,25 over sine of 120, 40, whoa, 11,83. Again, give or take with a decimal place. Okay, so again, we're just saying there's a rule that's always going to work, and maybe there's something that's kind of shown an example of it. So I'd kind of an in general, but again, the in general is just going to be if you've got some sort of triangle, doesn't matter, where you've got that, and let's go green, then if you go this side over sine of that angle, or the other way around, is going to be that side and the angle opposite it, and this side and this one over here. So kind of the side over sine of that angle. So if this here were A and this is A, then they're all always going to work. So this is maybe B and this is B, then that's going to be B over sine B. And the reason I'm not caught up in this rule is because it's just that thinking of it that's more important, like with the area rule before. So this one, I guess this would make sense to be C, so C over sine C. And the only thing maybe to notice is that you could flip all of these things around. So sine A over A, sine B over B equals sine C over C. But it's going to be clear from our examples which way around we want to do it. So let's run into a few examples. So in this case, we're given two sides and one non-included angle. So in other words, we're given a side here and an angle, and over here we're given a side, but we're not given the angle opposite it. And in this case here we're given not given that side, but that's what we're trying to find, and we're not given that angle over there. So according to our sine rule, we want to have angles and sides that are opposite. So we've got the 65 degrees in the angle and the side opposite it, right? There it is there. But what on this side we don't have this angle, but we do have the side length opposite it. Now it's going to be easiest if what we don't know is on the top left is in our numerator. So what angle do we not know? Well, you might say A because we don't know A, fair point. But what we don't know also is C, and C is the one we're going to find out. So in other words, sine of C over 7.8 is equal to sine of 65 degrees over 11. Okay, so there's our equation. Just one thing we don't know in this. C. So if we just want sine C over here, what do we need to do to each side of our equations? We just want sine C there. What do we need to do to each side of the equation? Well, if we multiply this by 7.8, those will cancel. What we do on one side, we do on the other. And so therefore, the sine of C is all of that. Now, if we get some sort of number, let's just get that number, why not? So calculator to the rescue, and we go sine 65 over 11 times 7,8. What do we get? Well, 0,642 blah blah blah, 0,64. Again, I want to put the 3 dots to just go, we don't want to round it off yet. How do we get what C is if that's what sine C is? Well, we use that shift sign idea. So shift sign of 0,4 blah 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 blah, and that should give us C. So let's have a look here. So we're going shift sign of that answer. Notice that I'm using answer. I'm not typing in 0,64. In fact, what would have been better is we don't even need to show this step over here, because we could have gone, well, shift sign of and put all of that in. Sine 65 over 11. I may as well have used answer this time, but because in future we don't need to, you can go, 39,99, in other words, 40 degrees. So if that's 40 degrees, let's put our 40 in now. And what is it? Purple. 40. Let's move that out the way. Just out the way there. 40 degrees. How are we going to find out what the third angle in our triangle is? Well, just sum of angles in triangle, right? 65 and 40 is 105. So 105, we're left with 75, is it? Well, let's just check. 180 minus 65 minus 40 equals 75. Cool. So our final angle is 75 degrees. Now, wait a second. We still haven't found out what A is. Well, for A, why don't we use sine rule again? So here's our sine rule that says A over sine 75 degrees, which we just found. And I guess it would be nice if we said A equals 75 degrees, sum of angles in triangle, equals, now we can pick either of the others. Why do you think I would rather stick with 11 over sine 65 than using the 40 degrees and the 7.8? Well, the 40 degrees we worked out, so maybe we made a mistake in doing that. So let's just use what information we're given as far as possible. So for here, we just need to multiply by sine 75, so they cancel. What you do on one side, you do on the other, and then punch it into your calculator. And what do you get? Okay, well, I don't know. That's what you got. Let's see what I get. Fraction 11 over sine 65 times sine 75, 12,56. I'm just going to say 12,7. Let's go to one decimal place. 12,7. If you went to 2, you went to 3, all good. 12,7, where's it? Just there. 12,7 units, centimeters, I don't know what that. Okay, cool. So looking good so far, hopefully. And so let's have a look at one more example. We'll do the ambiguous case in the next video. So let's get rid of that calculator. We'll need it just now. So we're given two angles and one side this time. Okay, let's start with first things first. What is the missing angle over here? How are we going to find out what it is? Well, sum of angles in a triangle, right? So our angle at x is 180 minus 36,7 minus 110,2. And let's just, somewhere over here is that calculator that helps us along to go 180 minus 36,7 minus 110,2. What do you get? 33,1. Hey, that's what I got too. awkward if you didn't get that. And I'll be like, well, I got something different, right? So there we go. 33,1. So I think I can squeeze that into the diagram. So definitely have the diagram and be filling it in as we go. So we got that relates to that. We've got maybe this angle relates to Z, and finally this angle relates to Y. Kind of useful to have these colors, I think. Just matches things up quite nicely. So in this case, I don't know. Should we find out what Z is first, and we can use that one. So now we definitely need, so what we don't know, let's put on the top left. Z over sine 110, 2 equals, or we must use something like this one, 8,5 over sine 33,1. So therefore Z equals all of that times sine 110. So in other words, times that part times it on that side. And I'm going to punch it into my calculator. And you know the question, of course, is going to be, wait for it, sine 33,1 times sine 110, 2. Oof, I think we're over there. And the question, what's your favorite color? Didn't see that coming, did you? So 14,6075. Let's go to one decimal place. 14, well, there it is on my calculator. I just want the colors to match. 14,6 to one decimal place. So that's that, 14,6. Kind of makes sense that it's longer than that one according to our diagram and opposite the biggest angle. Now this side Y should be between those two in length. Let's have a look. So Y we don't know, so we're going to put it on the top left. Y over definitely sine 36,7 equals, now we can pick either of the others. You know what, I'm just going to stick to this one we used before, even though we worked out that, again, we're just going to multiply by 36,7, and that's not too bad, so we're going to go, where's our fraction? 8,5 divided by sine 33,1, close bracket, times sine of 36,7. What do you get? Did you also get 9,3? I hope you did, but maybe you didn't. But if you didn't, have a look why you didn't. 9,3 units. So that's that. So that's how we work using our sine rule. Another very useful rule, kind of just use that. What we're going to look at in the next one is the ambiguous case, which, it sounds so interesting, doesn't it? Okay, well, make it maths another day. Let's make it maths now and enjoy.